So step 4 are calculations. When we're performing a test for if the null is that the difference in proportions is 0, we are assuming that the population proportions are equal. So remember, our assumption is always that the null is true. So we're actually assuming the proportions are equal, but we actually don't know the numerical value of the true proportion for the yawn seed and the true proportion for the not yawn seed. So to estimate this value, we pool or combine both estimates and create a pooled estimate. Now, this formula is actually a good thing to know, okay, because I have seen a few free response questions that ask specifically for a pooled value, or multiple choice questions that do. So this is a nice formula to know. I'll check in a minute to see if it's on the formula sheet. Oh, let's just check. I have some AP questions. Nope, it's not. Oh. Well, they don't really give it to you. They don't give you the pooled, how to find the pooled. So the pooled is actually really simple to come up with. You're just taking your n times p for your first sample and your n times p for your second sample, which we actually already did in the conditions, right? And then dividing it by the total number in both samples. So our p hat pooled here would be n1 times p hat 1, that would have been 10, plus 4. So in other words, the number of successes in both groups. How many yawned? 14 people yawned. Out of how many total people were there? 50. So 14 out of 50, or 0.28, would be our pooled p hat. And that's actually what you use when you're finding the standard deviation. This is the formula for the test statistic for a difference in proportions. Again, your test statistic in general is Z or T, and that's equal to your observed value minus your hypothesized or expected value divided by the standard deviation of your statistic. So our observed difference is our observed difference here. Z would be, what was the observed percent difference? The observed difference in the two proportions. 0.044. And what's the hypothesized difference? In our null and alternative hypotheses, what was the difference? 0. Subtraction means difference. So if I say what was the hypothesized difference, it was whatever the number in the null and alternative hypotheses were, all over the square root of the p hat and q hat are the pooled values for each part. So this would be 0.28 times 0.72 divided by how many people were in the group that got the yawn seed? 34. Plus 0.28 times 0.72 divided by how many people were in the group that did not get the yawn seed? 16. So that would be what you would have to plug into your Z, or you could just write this formula down. And you don't have to write pooled out, you just write p hat pooled, q hat pooled. It also says the two proportion Z test in the test menu automatically pools the two proportions. So what I'm going to do now is I'm going to write out the process. What do you actually have to show in your calculations? Okay, what do you actually have to show in your calculations? So here's what you would show on your step 4. I don't know where you're going to put this, but I'm sure you'll find a spot. You could do it like off to the side here. So, okay, so this is step 4, your calculations. You would have to write the probability that my p hat of the yawn seed minus p hat of the not yawn seed is greater than, what was my observed difference in those two proportions? 0.044. And then I would say, well, I'm going to change that difference into a z-score. This is a z-test because I'm dealing with proportions. So what's the probability that z is greater than, and I'm going to write my formula down. I'm going to write p hat of the yawn seed minus p hat of not yawn seed minus 0, which is my hypothesized difference, divided by the square root of. And another way to write this formula from this page, basically instead of having to write the p hat and q hat pooled on top of each part, you can just write p hat pooled, q hat pooled times the whole quantity 1 over 34 plus 1 over 16. So this would be, and you could put the numbers in here, but you really don't have to. You'd write p hat pooled times q hat pooled times 1 over 34 plus 1 over 16. Or 1 over n1, 1 over n of the yawn seed, and 1 over n of the not yawn seed. And the reason I want to do this formula is because actually you're probably not going to calculate the p hat pooled. Your calculator will do it if you use the test menu. So if I write the formula down, then my next step will be the probability that z is greater than whatever this works out to be, which I'm going to use the test menu, stat, test, and I'm going to go down to the 2 proportion z-test. So I'm going to turn my calculator on, I'm going to go stat, tests, I'm going to go down to the 2 proportion z-test. And it asks for, okay, how many of the people in the first group had the quality that yawned? 10 out of 34. And in the second group, 4 out of 16, and I'm trying to do greater than, and then I'm going to calculate. Now, here's what you need to know. It gives you the p hat pooled. The p hat pooled value is the one right here that just says p hat 0.28. Isn't that what I calculated before? So the p hat pooled is 0.28. And you usually just want to write that down as a note. And it gives you the z. So the z, if you do the calculation with the numbers plugged in, is 0.324. And then you get your p-value. What's your p-value here? Yep, the one that it just says p below the z is the probability that I was trying to find up here. So that is 0.373. And then I want to compare that to my alpha level of 0.05. How does that compare? That is greater than. That is definitely greater than. And so what do? What's our conclusion? We failed to reject the null. So back on this page, we failed to reject the null. Since the p-value is greater than alpha, we cannot conclude that yawning is contagious. So the difference of 4.4% was not significant enough under the circumstances. So Mythbusters made a wrong conclusion. All right, so now on to the last page. We are going to do our own test.